Your poop.
Right, guys, let's talk about momentum. So basically say an object is moving and we have another stationary object. So what we usually study in momentum is that if this is stationary, say this has a mass m and moves with a velocity v, say this also has a mass m and has a velocity of 0. When they hit each other, they might, like, there's different possibilities. One is that this might stop and this might start moving, right? That's one possibility. My God, that's one possibility. Another possibility is that they might turn into one lump stuck together and then like move with a velocity with something. So let's look at one or two of those possibilities. So usually what happens is when they're equal masses and the collision is perfectly elastic, like speed of approach is equal to speed of separation, what that basically means is that when this hits it, one of them will have to stop because you have to conserve momentum. So if this is before, usually what happens after is, if this was 1 and if this was 2, then 1 stops and 2 starts moving with a velocity v, mass m, and this is mass m, velocity is equal to 0. Right? So that's basically one of the possibilities. Another is, if it's perfectly inelastic, is that 1 and 2 can combine into one big mass having a mass of 2m, and because we have to conserve momentum, initial momentum is mv, final momentum will become half v final velocity, because the total momentum still has to be mv. If momentum before is equal to momentum after. So it's going to move with a velocity of half v with a mass of 2m. So now let's talk about two-dimensional situations, all right? So two-dimensional situations, it all goes down to that magical perpendicular stuff. So we'll have to figure that out. So what I'm going to do again is something that I like doing. I'm going to use different colors for different perpendicular components. So we're going to use...
It's a bad combination.
Yeah, that's actually red and blue. Yes, what is it? Yes, yes. These are going to be our combination. So red is going to be vertical. I almost wrote red. Like, wait, I don't have to write that. And this is going to be horizontal. Right? And for anything which is not horizontal or vertical, basically a combination of the two, we're going to be using black. Okay, so let's get going. So now say, let's give a really simple scenario where we have a ball and it hits another ball which is initially stationary. So now let's do some maths. So say this has a mass of 15 grams. I'm just making up values now. So say 15 grams, and it's moving with a speed of say 3 meters per second. So let's make this a little more. 150 grams. No, grams is a conversion rate to jhamla se. Always fun to, like, make people work a little bit. So say they hit, right? So once they hit, what's going to happen is this will move along a direction which is this, and the blue one, let's draw this with blue again, will bump here and it will move along a direction which is this. So now, say for example, we have these values, these are angles. So let's use purple to represent the values. So say this is theta 1 and say this is theta 2. Now, the thing is that we'll need to figure out what happens to the momentum vertically and horizontally. So what we're going to do is we're going to split this equation into two parts, all right? We're going to make it horizontal and we're going to make it vertical. So first of all, let's see what are the horizontal before and after. So momentum horizontal before collision is going to be basically the momentum of this, which is 150 divided by 1000 into 3, mass into velocity, plus the momentum of this. We didn't give this mass, let's give it a mass of say 100 grams. So that's going to be 100 divided by 1000 into 0. So that basically gives us a value which is for the horizontal momentum. Alright, so 150 divided by 1000 into 3. So that gives us a value of kota ashbe 1.15 times 3, so it's going to be 0.45. Isn't that right? So basically 0.45 kg meters per second. So that is our momentum horizontally. And what's going to happen is momentum horizontal after. Alright, so it's basically going to be the horizontal component of momentum of this mass plus the horizontal momentum of the component of this mass. So that's going to be 150 grams. Oh, we haven't given these values either. Say this is V1 and say this is V2. Alright? So 150 grams, basically 150 divided by 1000, because it's this mass, into V1 cos theta 1, right? Because this is theta 1 and cos is the horizontal component. Do you agree? Nice. Plus the horizontal component of this mass, which is going to be 100 grams, 100 divided by 1000 into V2 cos theta 2. So this is the horizontal momentum after the collision. So what's going to happen? This must be equal to this. Horizontal before must be equal to horizontal after. And now let's talk about vertical. So what is the vertical component before the collision? So momentum vertical, what?
Before collision?
Before collision.
0.
So it's basically the vertical component of this plus the vertical component of this, which is basically 0 plus 0. So we can just simplify this, but yeah, let's just write it all out. So it's going to be 150 divided by 1000 into the vertical velocity, which is 0, plus 100 grams divided by 1000 into 0, which is equal to 0 kg meters per second. And what is the momentum vertical after collision? So if we look at our equations again, what we're going to see is basically it's going to be the vertical component of this, which is going to be what?
V1 sin theta 1.
It's going to be m into v1 sine theta 1. And this will have a momentum in the opposite direction, and it's going to be, say, m into v2 sine theta 2. Yes, so they say this is m1, this is m2. Values this long, but I guess it's better if we start working with values from the next example. We're still talking about the concepts here, right? So the interesting thing is, because they're in opposite directions, one's going to be positive, one's going to be negative. Let's take the upper direction as positive and the downward direction as negative. So the momentum after the collision is basically m1, which was basically 150 divided by 1000 into v1 sine theta 1 plus, then we can put a minus here, minus basically, okay, let's put the minus a little later. Let's write the mass first. 100 divided by 1000 into minus v2 sine theta 2. And this has to be equal to this. So basically our equation for our vertical component becomes this long equation where it's basically all of this is equal to 0. And then you can rearrange it. So the thing is that when it comes to two-dimensional momentum questions, you have to split it into two parts. One which is purely horizontal, one which is purely vertical. So this explains the basic concept behind it. So we have 5 minutes. What we're going to do in the next 5 minutes is we're going to really, really quickly try to solve a question. We're running out of A4. So I'm going to give a classic scenario, a very common and a very classic scenario, which is something that, that they love to ask. So say we have a little rocket, a little satellite, and it's traveling at a certain speed. Say it's traveling at 350 meters per second, and it has a mass of 150 kg, and it's traveling at a certain angle. So the angle is 30 degrees. All right, so we have a lot of information right here. And say there's another asteroid which is traveling horizontally with a velocity of, say, 400 meters per second. And its mass is really high, say 500 kg. Right, this is big as asteroid. Oh, I can't see. Big teat asteroid. So asteroid. Oh, we should have used a different color for the asteroid because asteroids are brown,
or
man.
gray.
Huh?
Or gray.
Blue is going to be horizontal, and red is going to be vertical. Right. So let's start with blue. So momentum before. Momentum horizontal before collision. What is it going to be? Guys, pull your calculators out. We're going to need some help for this. So it's going to be basically the momentum of this horizontally, which is basically 500 into 400, right? So it's going to be momentum of this horizontally, which is going to be 500 into 400 meters per second, plus the horizontal component of this, which is going to be 150 kg into 350 cos 30. So this is basically the momentum of the whole combination, right? Did I say anything wrong, guys? Okay, brown is going to be asteroid, and purple is going to be satellite.
That's a lot.
Yes, we're talking about big things flying through space. So it's going to be a lot.
I don't trust myself.
It's okay. Don't worry. If you make a mistake, nobody's going to know because you're a mystery student. Okay. Okay. So moving on. So momentum of this plus momentum of this, huh? Oh wow, this is a huge value, guys. The value is 2466765.3718. Obviously, we're not going to write it to so many significant figures because our values seem to be around 2 sig fig, 2 or 3 sig fig. So if we write it in 3 sig fig, then we can write that the momentum before the collision, the total momentum before collision, we can write sum here because it's the total of it, is going to be equal to 246 or 247 actually, 247,000 kg meters per second. Right? So that's the total momentum horizontally. So before the collision. And let's write the total momentum, sum of momentum vertically before collision. What is this going to be? This has no vertical component, so we can write that really easily. We just write 500 into 0 plus vertical component of this, which is going to be 150 into 350 cos 30.
Vertical to cos of it.
Oh wait,
Sine.
my bad. Sine
Catch,
30.
that's a good catch.
Good catch. Mystery student is smart.
Okay.
Do not underestimate the power of the mystery student. So again, we're going to use purple to represent the satellite, and we're going to represent the asteroid with brown. Right, so what is this value? Guys, come on. Maqsood.
150, 350.
Basically, this is 0, so it's 150 into 350 sine 30. Come on, quick, we're running out of time.
5.
Are you serious? This is so less? That's so small. Shut up, Maqsood. Did you do the calculation properly?
That's what you wrote, right?
350 sine 30, yeah. Alright, so this is 325 kg meters per second. We should increase some values here, shouldn't we? এত কম কেমনে হয়? Sine 30 is equal to half. Maqsood, I'm going to hurt you now. Into 350 is equal to 175. Into 150 is 26250.
What do you mean?
What do you mean? Do the calculation again.
150 into 350 sine 30 now?
Huh?
Oh, I added it.
Alright, added
Because I'm
it.
looking at it from an angle and you're multiplied.
250 26300
Addition.
kg meters per second. 26250, right? So 26300. Yeah. Keep making excuses. Alright. So now what's going to happen is they both stick together. What? So they basically bump into each other and say the satellite sticks to it, and they both together start moving along a new direction, which is this way. Right? So now here's the important part. Once they're stuck together, horizontally the momentum needs to remain the same, and vertically the momentum needs to stay the same, and horizontally the momentum needs to stay the same. So that means this combined mass of the satellite and the asteroid will have a vertical momentum of 26300 kg meters per second, and it will have a horizontal component of 247,000 kg meters per second. This and this, right? Now, what's going to be this angle? That's going to be question number 1. And question number 2 is going to be what's going to be this velocity. So, easy way to answer this is first we find the combined momentum of the two, right? We can do Pythagoras for that. So, can you tell me the value, the Pythagorean result? Please use your BODMAS rules properly, right? So, we'll be getting that value in a minute. But basically the concept is that the velocity is going to be, we can use the equation momentum is equal to P is equal to mv. So the momentum, whatever it is, velocity is going to be momentum by mass. So the mass is going to be how much? It's going to be 500 plus 150. So that's 650. So whatever value we get divided by 650. What is that value? Look, it's sliding in here. It's 2. Did you do this properly? Okay, we're seeing some solid maths right there, right? So if his work is correct, so it should be 248000. Right? That's what this says. So let's just 248000 divided by 650 is equal to 382 meters per second. That is the resultant velocity in this direction. Pretty good, pretty good. And can you help me do one last sum and tell me what is going to be this angle? How would you do that?
Just what is it, tan?
Yeah, tan theta. Because this is our, if we look at this as a vector triangle, basically this would be our opposite and this would be our adjacent. So tan theta is equal to basically opposite by adjacent, opposite being 26300 divided by adjacent being 247000. It's going to be a pretty small angle.
6 degrees. 6.07. 6.07.
6.08 degrees. So 382, 6.08. Right? So that's basically how we find the resultant momentum and the resultant velocity. I won't say it's easy, but if you understand the concept of it, that you split it into two sums, one sum which is purely vertical and another sum which is purely horizontal, then you can actually find the answer.